Thanks, Yolanda.
Okay, so hello everybody to our repeat session of the FAIR for Machine Learning Interest Group. And thank you for joining today. So these are our slides, and we have the link to the slides here, so you can easily find them. But we also have the link here to the collaborative notes. So I'm going to give you a couple of seconds for you to find these collaborative notes on your browser. And then please add your name to the attendee list for the second session. It will be on the top of the document, so you will not get confused with the first session. So this is the repeat session for the FAIR for Machine Learning Interest Group. We have here some information about the etiquette, like the code of conduct that you can read, that it's for RDA and all the event and all the meetings that happen in RDA. If you have any questions, please add them in the chat. Raise your hand if you want to speak. We can just help you with that. And add your comments to the collaborative doc. We will have some interactive sessions with you, so using the collaborative document will be very important during this meeting. So let's go to start. This is the agenda of the first session. So let's go to jump to the agenda of the second session, which is the one that we are having right now. And I'm going to, yeah, much better. Now I can see the screen. So we are starting with the welcome and introduction. Then we will have a brief introduction to the interest group, including objectives, the structure, and very, very important, how to join if you are new to the group. Or you are not you knew about it, but you didn't have the time to join before, so now you can join. And then we will have some updates from the current task forces that exist nowadays. Task Force 1 about FAIR for Machine Learning and the Machine Learning Lifecycle, and Task Force 2 about metadata for machine learning models. We will have one invited talk today. It's a structured data for Hugging Face, and for that we have an invited speaker, Wenxin Yang. I hope I did not totally mispronounce the name, but well, he will be telling us more about this structured data for Hugging Face. So let's going to start with the welcome and introduction that I'm going to run at this time. So the FAIR for Machine Learning Interest Group, as you realize already, is an interest group rather than a working group. So it means that we are not running on this regular schedule of working groups of 18 months, but kind of more freely. So we have organized everything around discussions and task forces. And right now we have some task forces that are discussing elements in the machine learning lifecycle, the FAIR principles for machine learning, and metadata for machine learning models, and how it all connects with the FAIR principles. So these are some of the possible outcomes that we think we will get out of these task forces. Some of them will become kind of official outcomes after a consultation period. Some of them will be supporting outcomes. But we think that we can show some use cases relevant to FAIR for machine learning and definitions that will help people to understand what is this FAIR when it refers to machine learning, some recommendations and guidance for people to apply FAIR principles when dealing with machine learning approaches, and also some links and maybe training, maybe guidance, maybe recommendations together with other RDA groups or with external networks such as the Pistoia Alliance, Elixir, and so many others that we are seeing, for instance, here. These are some platforms, communities, projects, and that we have already identified. We have people from these platforms, communities, and projects participating in the interest group and the task forces. But if you think that we are missing anyone here, please just let us know. We would be interested in knowing more about platforms, communities, and projects that have some link to what we are doing here. How to join, very important. So we have a mailing list. You just need to join the group and then you will start getting the emails. Please be aware that Research Data Alliance website is still under change. It was recently migrated. So if you see that anything is not as you would expect it to be, just please leave the feedback. But this is the regular way that you join either a working group or an interest group. You just say you want to join, and straight away you start getting the emails. We have monthly meetings on Zoom, and you're welcome to join them. On the even months, the meeting will happen at 8 a.m. UTC. On the odd months, it will happen at 20 UTC, so 8 p.m. UTC. And we send reminders every month right before the meeting using the mailing list. You can join any of the task forces that you're interested in. Of course, you can also volunteer to run a total new task force if you find that we are missing something that it is important for the FAIR for Machine Learning. And for asynchronous discussions, we have Google Drive, and we also have a GitHub space. And we will soon start using the RDA open consultation elements on the website. So the goals for today, we are going to review what the different task forces, the 2 task forces that we have right now have been doing, and we will have some updates from additional relevant communities. In this case, the group that we mentioned that have been working on structured data for Hugging Face. And we will present the progress that we have done so far for FAIR for Machine Learning and how we are going to continue with this. And with this, I'm going to give the word to Dan so he can continue with the task force. Dan, do you want me to do the next whenever you say that I should move the slides, or do you want to share?
If you don't mind, I think it's easier probably just to continue. Without...
Okay, perfect.
Great, thank you. Yeah, so I'm gonna talk about Task Force 1. We'll go to the next slide. So Task Force 1 is really basically, oh, sorry, and I guess I should have said I'm Dan Katz from University of Illinois, sorry. Task Force 1 is looking at how the FAIR principles are applied to machine learning. And we're doing this in some sense based on past work that's happened within RDA, and that a number of the leads or other members of the group have been involved with. And so one thing that we did about 2 years ago was we defined FAIR principles for research software. And we're basically, I would say, in this interest group, we're using a similar methodology to how that working group worked. But we're also looking specifically at the output of that, of the FAIR principles for research software. There was also work done around the same time and maybe a little bit earlier on FAIR workflows. And so the idea of both of these working groups was the fact that we have FAIR principles, that FAIR as an acronym, as a concept, has a lot of buy-in. But the details of how FAIR was originally defined have a kind of a bifurcated, I don't know, property in some sense, that the FAIR principles themselves in the original paper are very much focused on data. But there's also text that says that the FAIR principles should be applicable to things that aren't data. And so how that actually happens, I think, is the challenge. And that's what we did in these 2 different working groups, was to figure out how exactly to translate and interpret the FAIR principles for both research software and for workflows. And so now we have machine learning models that we've turned our attention to. And when you think about machine learning models, you might think that a model is really data in some sense. It's a set of parameters and options that go with a particular framework. You can think of a machine learning model potentially as being software, right? Because it's an executable object that takes input and provides output. You could think of a machine learning model as being some combination of data and software and workflows. Or maybe machine learning models are something else. And so when we started this interest group, we were thinking about potentially that a goal might be defining a new set of FAIR principles for machine learning models based on these other two activities, as well as the original FAIR principles for data. But we kind of expanded a bit, and we want to now look at how the FAIR principles are applied to machine learning in general, not just to models. Okay, so let's go on to the next slide. And so effectively what we're trying to do in this task force 1, is to develop a white paper on how FAIR overlaps with machine learning, how FAIR applies to machine learning, something like that. And we're doing a few different steps. These aren't exactly sequential, but they're kind of sequential. And I'll talk about each of them in a little bit of detail. So first is just a literature review on what's been done previously, how FAIR has been thought of in terms of machine learning. Second one is defining a machine learning lifecycle. Third one is trying to understand how FAIR applies to each step in that life cycle, each phase in that life cycle. And this is where the third and the fourth are actually kind of similar to each other, and I'll talk about them together, I think, in a couple of slides. So let's go into the next one. All right. So in terms of the literature review, we have a Google Doc where we tried to capture previous work. And the documents that we've been looking at are in a Zotero collection. And so again, if you start at the notes document, you can get to the slides, and then you can click on any of these documents from the slides to get to them. The Google Doc is really kind of trying to look at the documents in the collection and take notes, organize them, summarize them, try to think about how they actually work, where FAIR fits into them. Okay, next slide. In terms of defining the machine learning lifecycle, there was a mini hackathon that was organized or run or both by ZBMed about, I guess, 6 months ago now, and the notes from that are available. But that produced a consensus on a simplified structure for the machine learning lifecycle that'll be the next slide, and then also started to look at what FAIR means for the life cycle, and in some sense how it applies to different pieces. And so there is a preprint available, but let's go on to the next slide and actually look at the picture. So, the way that this mini hackathon thought about things is that the machine learning lifecycle in some sense has 10 steps. This isn't exactly right, but it's a good starting point. In some ways it's simplified, in some ways there are things that are ignored, but it seems like it's kind of a key part of this. And so we start at the top with a problem definition, and then that potentially leads into two different pieces. Actually gathering data is potentially step 2, and starting to think about methods, which in some ways is step 4, but it can be done partly, at least at the beginning, in parallel with step 2 as well. Step 3 is actually, once the data has been gathered, to get it into shape so that it can be used in training. And so once that's done, then you can go back into step 4 and actually kind of finally select a method, or do the final selection of a method, and start doing that training. And that then leads into model creation as step 5, model evaluation then, once you have a model, is step 6, and model validation is step 7. And so at this point, the model validation is dependent likely on some part of the data, some part that hasn't been used for training. But it also may provide some feedback that you need to pick a different model. You need to do something different in terms of pre-processing of the data and to retrain that different model or that same model. So there's some iteration that can happen here. But once you do get to a validated model, then you can think about actually deploying it and monitoring it and using it effectively. As step 8, and then step 9, that you also may want to store it and share it. And step 10, that somebody else may want to, or even you may want to reuse it. And reusing it may involve just really reusing it directly, or it may involve altering it in some way. And so I guess a good foundation model in some sense could fit into this kind of a workflow as well, or this kind of a life cycle. So that's kind of an idea of what we were thinking of as those 10 steps. As the slide says, there also is publication, documentation. There may be other monitoring of the process, and this doesn't really talk about the life cycle of the data itself or the life cycle of the software that's actually implementing the model or deploying or operating or monitoring the model. So there are some things that aren't in here, but this is really focused on the machine learning part itself at this point. So maybe I'll just stop there for a second and see if there's any kind of questions before we go on to the next piece or any discussion.
No, I don't see anything new on the chat. I don't know if in the document.
Yeah, no, I don't either. I can see the chat quite easily since I'm not presenting as well as the document. So okay, so let's go on then at this point to the next slide. So yeah, so 3 and 4 again, which are kind of similar, are thinking then about how does fairness actually apply to these different steps, to these different stages. There has been, well, actually, so what we would like to do at this point is actually kind of get you to kind of help us with this, to think about this a little bit. In the collaborative notes document, you'll see under the place where you signed in, then there's the little session for notes where you can add things. And then there's task force 1 activity, session 2, which is what we're doing now. And so the question that that we'd like to do is to just take a little bit of time here and ask you to think about, for these 10 different steps, which FAIR principles are relevant in each, and in some sense, what part of them is relevant? Is it something that's relevant from the original FAIR principles that's relevant to the data? Is it something that's relevant to software? Or is it something that's relevant to the model? And also, if there's something that seems like it's missing, to let us know what you think is missing. So again, I'm going to just kind of stop and pause for a few minutes. And if you are willing to put in something, that would be great to, again, help us. And if you have questions and I'm not being clear, then please ask. Okay, so we'll stop for a couple of minutes, and if you can put something in, that would be great.
Yes, Ghana, I saw your hand raised, yes?
Yeah,
Oh,
yeah,
Yeah,
that's
please.
right.
Sorry, please speak up.
So this is something that we had worked on probably a year or maybe 14 or so months ago. And so that's, yeah, so I mean, are you looking for new input or, because in your slides, I see one of my documents that probably was about 14, 15 months ago. Yeah, so that's, are you looking for a fresh perspective or
Yeah,
is it,
yeah. I mean, so I guess I would say basically because we have new people here, at
sure,
least a few. Yeah, so we're just looking to gather what people are thinking, and we did this in the first session as well when we
sure,
had quite a few more people, and then yeah,
sure.
you've done this and you've been part of doing this. So this is a process where we're not. I would say we're not trying to iterate exactly, but we're trying just to gather multiple inputs and then bring them together.
Sure. But while we are at it, I would pose a different question. How does fairness apply to this new generation of AI, Gen AIs and so on? And where does fairness lie in these cases?
Yeah,
because we are talking about a different fairness in this case. That's that's often discussed, but I'm talking about the traditional FAIR.
okay.
Yeah.
Right. I guess my quick answer, and then I'd be interested in hearing what other people think as well, is that I don't actually think it's different, other than the model effectively is coming from a different place as opposed to us developing models. But again, if we're thinking about foundation models, then maybe it's even closer, that it's a model that's coming from somewhere else, but then maybe we're doing something to it to apply it to a particular problem.
Sure. Primarily I'm thinking about the findable is well managed by some of these repositories and so on, like Hugging Face. But interoperable is better. So is in a way reusable. But how transparent are these models? So
yeah. No, I think that's a really good question, and that okay. So I guess I'm thinking about this in two different ways, which is how does FAIR apply to the process that's happening as being separate than, is that actually happening? So in theory, right, if I was building a large language model, and we just leave aside the idea that I have no idea actually how that happens, but just skip that for a second, then I would hope that I would be making the data that I was using FAIR and making
that's one. That seems like that making that data FAIR seems like a hotly contested thing, especially when you are sweeping and everything.
Yeah. So I completely agree with you that there's lots of challenges in practice, both maybe what can be done as well as what is being done. Sorry, Lars, were you going to say something as well?
No, I was just going to say that I think in these cases, it's actually even more important that we take care that the whole process is made using the FAIR principles, because as we're going further away from control, or like if we're looking at sweeping, for example, then we have the responsibility to be very open with how our models are doing things and how we're gathering the data. So it becomes even more important that the process that we're developing under is actually following the FAIR principles. So I think it's even more relevant to apply these principles in the modern scope and like large language models and these things that than it has ever been.
So I don't really see much more typing happening. So I don't know, if there's any other discussion potentially? Or if not, we
Yeah.
can.
Other one I would raise is, at least from this region, is for a while it has been a bit difficult for us to participate, especially when the time moves into 2 o'clock in the morning for us, and so that gets harder. But thanks for putting the second session. But I also appreciate that someone needs to be on both to actually run the repeat thing, so which is not an easy task. And so what could be the solution? I propose, since we are only a few of us, I propose that we work asynchronously, but that did not work as much, and because I'm actually losing out on the things that are happening on that side.
Yeah, I mean, I'm in the same position you are, because one of the meetings for me is at 2 a.m., which isn't a time that I'm going to make. So it's the other one that I can make, except that when it's every 2 months and I'm not always here, then I end up missing. So then it's like 4 months between meetings. I completely lose track of what's going on. So I completely agree with you that we need to do a better job of doing things asynchronously.
I mean, if we can work asynchronously, maybe the meetings could be either briefer or something else. Then,
yeah. The other, I guess the other thing that's interesting to think about, but maybe isn't practical here, is that in one of the other organizations I'm involved with, Research Software Alliance Funders Forum, we also have meetings that are 12 hours apart each time, repeated, but we shift them 4 hours by 4 hours each time we do it. So sometimes we get basically America and Europe, and then like kind of West Coast of America and Australia are together, and sometimes it's Australia and Europe are together, and the Americas are separate. So it ends up actually kind of creating a little bit of differences in how
equitable distribution of misery.
Yeah, but it also means that we don't ever have groups where, for example, like where you and I are not going to be in the same meeting. So we get kind of different groups of people in different times, which is good.
Sure.
But unfortunately, in this group, sorry, Leila, we're the vast majority of the organizers are in Europe, and so we get times that work for Europe and North America, and then Europe and Asia or Oceania, but not kind of the other ones, because we don't really have enough of us to kind of do that. So I think the asynchronous thing suggestion really is what we should try to do.
You don't have to cater to every zone, but as long as that possibility exists for someone to pick it up in the following week or next day and continue. And otherwise, we come and give input asynchronously, but it's probably you may not even look at it. Or so that's so if that is kind of formalized, and that certainly would happen.
Right. So let's.
I don't think you need to cater to Australian zone per se.
So Leila, I'm not sure if that's. I don't know who's typing in the discussion, but I'm glad somebody is typing.
I'm trying to capture the discussion.
Okay, great. And I think it's important to get it here, because otherwise It's not obvious that somebody's going to watch, that all the organizers who aren't here are going to watch this video, but if it's in the discussion notes, then they will see it. Okay, so I'm just going to put in one more thing for a second, and then we should go back to the maybe we'll go back to the presentation then.
Sure. Sorry.
So, I mean, according to our schedule, is 1 more minute for the feedback for task force 1. So I think we can move to the next point in the agenda, that would be the task force 2. So just allow me a moment, and I will share the screen again.
Okay, yeah, I wasn't sure if there was one more slide for task force 1 or if that was the end.
I think that was the end, but let me double check. So now you are seeing.
Right. Yep.
Just give me a moment that I have to move the Zoom bar to be able to. Yeah, so this was the last slide for task force 1. But if you want to conclude this activity, let me just start there, done, so you can wrap up this task force.
Yeah, no, I think that's probably good for this point. Again, because of the way we're doing things, we're really trying to give as many opportunities as we can for things to happen. And as we've been talking about, they don't necessarily happen always in those meetings, and the asynchronous part where we try to do things isn't always as successful as it could. So we want to use these RDA sessions as a way to get a little bit more input from people potentially that haven't been as involved. So thank you for that, and I think we should go on to task force 2.
Yep.
Okay, so that would be me again. So I will continue with this overview of the task force 2. So it was Daniel Garijo from the Polytechnical University in Madrid who presented this on the first session, and it will be me, Leila El Castro from CERVEMED, who will present this summary of the task force 2 in this second session, repeat session that we call it in RDA. So let's going to start with the overview. So what is this? What we have been doing in task force 2 is metadata, working on a metadata schema for machine learning models. So if you think about the FAIR principles and the way that you describe machine learning models, there are different elements that are related and different things that you will want to describe. For instance, the training data sets, if you are using one, the software that it is actually used to train, optimize, and to finally create the model that you want to expose to the public, which is the one that we are highlighting here because is the one that we are focusing on in terms of metadata definition. But there are other things that will play a role as well. For instance, for the extrinsic cross-validation or evaluation, you will most likely have an unseen data set that you are trying for this cross-validation or evaluation. So that should be also described. And for the deployment environment, you might also want to describe some things in terms of metadata, but we are focusing particularly on the machine learning models. So kind of the output from the software after the training and optimization process. So what was our approach to create metadata for machine learning models? So we started working with the machine learning model cards and dataset cards that were proposed by different groups. We did a literature review, which is still ongoing. It's still open, but we started with this. And then we decided that one way to go would be mapping the machine learning model cards from different platforms to schema.org, and we use initially the machine learning model cards from Hugging Face to do this mapping to schema.org. Why schema.org? Because it has been used successfully in other scientific research academic instances. Some examples of these are CodeMeta for software, bioschemas, which also cover a little bit of software, workflows, but also data sets and training materials and so on. And the barrier to use schema.org is kind of low, so people are getting more used to it. So we thought, let's going to just propose an extension for schema.org so people can use things that they are already familiar with and extend and combine, for instance, with descriptors, metadata descriptor for data sets and so forth. So this is why we are working with schema.org. The two main drivers from this task force is at the Polytechnical University in Madrid, particularly with the project Ines Data, that you are seeing the logo of Ines Data here, and CERVMET as part of the project NFDI for Data Science in Germany, that it is one of the national research data infrastructure projects in Germany, one of 26, I think it is 26. But this is also done in collaboration with Elixir and, of course, with the Research Data Alliance. So here you have the links. It's not that we are going to look in depth in all these elements right now and right here, but you have all the links to the literature review, and you have the links to the crosswalks. So these crosswalks, we have put them in a GitHub space that we created for this whole group, for the FAIR4ML interest group. And we are hosting there the metadata schema and the crosswalks for the task force too. More repositories can be created as needed. So these crosswalks also come from a mini hackathon that was run. This one was run right after the definition of the machine learning life cycle. So it was kind of November last year that was organized by CERVMET and NFDI for Data Science. And we work mostly on this crosswalk from Hugging Face machine learning model cards to different platforms that were present in there. Some of them are also part of this interest group. For instance, AI for Life. We also look into the data optimization model and evaluation recommendations, the DOM recommendations, because they also discuss the modeling there. And as part of the regular work of NFDI for Data Science, we are looking into crosswalks to other platforms, for instance, OpenML, that we didn't do during the hackathon, and any other platform that you want us to suggest. We are happy to have a look and look at it and add it to the crosswalks. So the idea is that these crosswalks, kind of similar to what CodeMeta has done, will keep growing, and well, hopefully we will also be able to update it if the platforms change. Updating and maintaining the crosswalks is more difficult than creating the initial crosswalks, because it needs kind of checking the original platforms for any change. The metadata schema then is also hosted in GitHub. So initially, Ines Data from the Polytechnical University in Madrid, they created their own kind of approach for metadata for machine learning models. We did the same in CERVMET for our ML entry registry for machine learning models. And then we came together and we asked for initial feedback from the FAIR4 Machine Learning interest group and our own communities as well. We discussed kind of like a middle point, because as you can imagine, there were points that one would say A, the other one would say Z. So we really tried to find out a middle point. So we came up with the version 0.0.1. And this is the one that it is currently public in the GitHub repository. And what we want to do now is starting with some feedback. So we will start with some feedback at this meeting, But as part of our next steps, we also want to ask for feedback to the broader community. And for this, we want to use the consultation period that it is commonly used in RDA for official outputs. With all the feedback that we will get from the community, what we will do is incorporate this into the schema. So it moves from version 001 to 002 until we get something that we see that it is stable, that people are happy with. So we can have like a version 1.00. We will keep working on the documentation, the website, examples, and adoption. Of course, examples and adoption will come later. The two projects that are already kind of directly working with the metadata, we suspect they will be the first ones doing the adoption, but we would really like to see broader adoption of these. And if we actually get some of the machine learning models platforms adopting directly these, that would be a super win situation, because it would really make it easier for people to combine data from the multiple platforms and so on. And the idea is that we will keep working on the crosswalks, and the crosswalks will also become part from the FAIR for machine learning, regardless where they originated, in one institute, in one community. But we want to collect them all in the GitHub repository so everybody has access to them. We are using for the crosswalks, by the way, kind of tabular data, tabular tables, so separated by tabs rather than by commas. So it's easy for anyone to actually read these crosswalks and see what we did. We also provide kind of a spreadsheet version that, for instance, we use during the hackathon, just because for humans it will be easier to visualize. But for machines, we are providing these tab-separated values. So here we have an example. As we mentioned, we use the Hugging Face model cards that it is created in YAML. So what we did was kind of looking into the specification for the Hugging Face model card. Here you have like a tiny bit of a model card coming from Hugging Face. And we did a mapping to schema.org. So initially the mapping was done independently by the two main projects that are working on this, the INES data and the ML entry registry in CEPMET, and the other one in the Polytechnical University of Madrid. And then we combine these. But we saw that in some elements, for instance, we need an identification, we need a name, we need a version. There was a total agreement. And those basically are the ones that are becoming part of version 001. And there is not only an agreement between the different parties, but these things are already supported in schema.org. They are part of what it is called creative work in schema.org. By the way, in case you are not familiar with schema.org, maybe I should say some words about it. So schema.org is a control vocabulary that was proposed initially by search engines. So people could describe with this vocabulary what they were exposing on the websites, initially to make life easier for the major search engines, but it has been broadly adopted by the community. The e-commerce community uses a lot of schema.org, but the scientific community, thanks to Code Meta by Schemas, schemas on science, there has been also a broad adoption of this schema.org. So it's just a control vocabulary, so you can describe what you have on your web page. The recommendation nowadays is describing this using JSON-LD. So now, coming back to our next activities, so we would want to invite you to start right now in this session to provide some feedback. So just let me quickly go to here. So you should still be seeing my screen. So for those of you that are kind of happy reading JSON-LD, you can look into the JSON LD that has been created, that has all the properties that we consider are important for this version 001. If you are not that comfortable with JSON LD, but still you want to provide feedback, we also have a spreadsheet that has the properties. So what we are proposing is that we will create a new machine learning model type in schema.org, that it is extending creative work in schema.org. What you are seeing here would be the hierarchy in schema.org. And you can see here what are the new properties that we are proposing for the machine learning model. Later, you will see also the properties that directly come from creative work that we think are the most important ones when discussing machine learning models, and some others that will come from think, because as a vocabulary, it also is including all the elements that are in the parent of the parent, and so on until get to the root. As you can see here, the path to the root is not that long. We start everything with think, then we move to creative work, then we move to our proposal for machine learning models. So this is what we are going to do now. Here on the activity for the task force 2, you can just add comments to here, discussion, comments, notes. Just feel free to directly add your thoughts in there. Or if you want, you can add your thoughts as a new column in here. It should be available for everybody. If it doesn't work for you, if you don't have editing permissions, just let me know and I fix that straight away. But it should be shared for everybody. So you can start adding here kind of your comments. It makes sense, it doesn't make sense, or you can just in here saying like, oh, yes, it looks fine, but you are missing to say something like deployment platform, or something that comes to your mind that it is very important for you when you are describing machine learning model approaches and you want to present this to the public. What is the metadata? What are the descriptors that you would want to see in your own approaches, but also in someone else's approaches, if you want to learn better through the metadata descriptors what someone else's machine learning model approach is about? So we have these different elements for feedback right now, so you can use this document or you can use the spreadsheet. When we open the consultation, we will also open the issues on the GitHub. Sorry, I missed the GitHub. Yes, here is the GitHub, and the regular channels in RDA to make things easier for everybody. So we can start work on that right now. We don't have new questions, but just the reminder of the notes. And right now we can also take questions. If you have any questions about this metadata bit, comments on discussions, on just start adding your notes here. I'm going to stop sharing a moment so I can also see if we have any raised hands or.
Just a quick question. Some of these are quite broad. Like if you look at ethical, legal, social, that's quite a spread. And what's the idea that you want someone to put into that field? Like it's a text range, yes, but like what's the...
That one, for instance, we leave it kind of very open, so people can put anything from the ethical, legal, and social aspect that they think people should be aware in relation to the machine learning model. We didn't do it kind of more structured, let's say, because metadata for machine learning models are still kind of new for people. Even the machine learning model cards are new for people. So what we have seen is that if we put a high barrier, like we really want to go for very structured data, we want you to tell us this information in this and that way, we are making it more difficult for people to provide this data. So that's why we went to broadly just let us know any ethical, social, legal aspect that you think is important to disclose to the community that possibly will be using this model. We can imagine in here that, for instance, you can disclose if there was any bias or you are aware of any bias in your data that you want to make explicit. Ideally, bias in the data should be explicit through metadata for the data itself, but it doesn't always happen. So you can give here kind of a statement on the biased or ethical or social aspects.
You have the sheet or the Google Doc has two sheets. One is named VR0.0.1, other one simply sheet 1. Which one are you actually referring to?
It should be only one. The spreadsheet, you mean it should be only one unless I have the wrong link.
No,
Yeah, the one that you the one that you showed on on the screen had only one sheet, but what I have seemed to have two.
well, it's I don't know. The link that I put in chat seems to only have one for me, and that's also what I clicked on from the notes document.
Yes,
Yeah,
you might
opened
have seen two, Ghana, because you are part of the group. So you have seen kind of the pre-discussion to get to version 001. But just to make it easier for people here doing the meeting, this spreadsheet only has kind of the conclusion, version 001.
I mean, I guess, Leila, sorry, I wasn't involved in this task force, so this is new to me, except from the last meeting briefly. But I guess I wonder, the places where there's text, I mean, maybe this is what Lars was saying as well.
Yeah, agreed.
I guess we should try to avoid having just open text, and we should try to have, I don't know, structured vocabularies or choices or URLs or something else, because it seems like if we just have text, it's going to be very hard to know what to do with it.
Yes, this is kind of also part of the discussion that the two main groups that have been working in metadata have, because one of the groups want to go for what is easier for people to fill in, that would be text. The other group, as you're mentioning, would like to have more structured metadata, but we are seeing that it will be difficult to obtain. So kind of the middle point that we will find that it is not yet reflected, because we also want to gather the information, the feedback from the community. What we have seen is that, as it happens with many other properties in schema.org, we will have multiple possible ranges. So text, and if you only want to commit to text, okay, that's fine. But for instance, it could also be something that in schema.org is called property value, and we will give you examples on how to provide these. And it is up to the people providing metadata or creating the metadata automatically out of maybe information in the model cards on how to actually provide these. But definitely we need to work more on the ranges to cover and to give more structure to the data. Yes.
So how does this handle multiple input? I mean, multiple data points. Yeah, author, for example, may need to be more than one. Is it like simply some comma separated entities, or
I'm not sure if I understand the question, but you're saying
So-
data
so,
points, you refer to data sets, correct?
Correct. No, if you are defining a model card, some
Mhm.
of them will take a single input. Some might take multiple inputs, meanings one to many.
I'm not sure what you mean by
But the
input.
cardinality, in the sense it can, some fields will have multiple
Okay, sorry.
possible
Now I
values.
understand. Like, okay, for instance, name, it's usually one when rather than authors, for instance, will most likely be more than one. This is what you mean?
Yes, yes.
In schema.org, everything is many by default.
Okay.
Everything is many, everything is optional. What we think is that as it has happened with CodeMeta, with bioschemas, for instance, sub-communities will take this and will say like, okay, particularly for the biomedical domain working with synthetic data, we always want the a license to be only one. So they can further restrict that, but by default it's always many.
Okay. Okay.
Yeah. Okay, now for the sake of the time, I think we should move to our next item in the agenda. So quickly, I just will go again to the slideshow. Sorry, I have to share the screen again. So we had a presentation from Croissant dataset from Machine Learning Commons on the session 1, but on session 2, we have Wenxin Liang that will present PATMOS, a dataset and initial analysis of pre-trained models in open source software. So I'm going to stop sharing so you can directly share your slides. And then we will have this invited talk.
Yep. Can you see the screen here?
Yes.
Okay. So first, thanks for inviting me to give the talk here. So this is one of my work which I presented in the International Conference of Mining Software Repository. And this basically we present the dataset called PITMOS. So this is dataset for pre-trained models in open source software. And so basically we have 4 contributions in this work. Basically, we provide a SQL database, which includes 208,000 pre-trained model packages and also 28,000 downstream GitHub applications. So this GitHub applications are basically like the GitHub repository, which reuses pre-trained models. And also we extract some unstructured metadata using LLM, large language model, and we extract the metadata from the model card, which is like a unstandardized way. And using the data set, we provide some initial measurement of which we call pre-trained model supply chain, and we assess some pre-trained model license compatibility with the downstream GitHub applications. So this has a 4 main contribution of this work. And some background and motivation here. Pre-trained model packages, I think most of the people here are familiar with this. Pre-trained model is basically like a deep neural network, which is trained on some general data sets. And there are a lot of like model hubs, or we call it model registries, which is similar to like traditional like software package registries like Hugging Face, TensorFlow. So these are like similar to maybe like NPM, PyPy, which provide like software packages. And this pre-trained model packages, it includes like not only traditional package components like code dependencies, like some documentation, traditional metrics. It also includes like some additional components like the weights, what's the architecture, what's the data set used to train the model, what is the model format, what are like the deep learning specific metrics, like what is accuracy, latency, like this evaluation metrics, and also like what is the fine-tunability of the model, for example. So this is an example from Hugging Face. So this is the mixture model from Hugging Face. And this is the the page of this model. And basically in this page, you can see this include like some metadata, or like I think this is called model tags on Hugging Face, and what is the monthly downloads, which is the popularity of the model. And this is the architectural information, which includes like the model size, number of parameters, what's the tensor type. And then it also has like the model card, which is like kind of like a README or like the documentation of this model. And the model card usually include like a lot of information, like including like what is the input output, what is the example usage, what is the data set of the model. So all these are like in not in a like non-standardized way or like unstructured way. And this also include like some this is the demonstration of how to use this model. And the example usage of the pre-trained model package. So this is an example for Brave, which is one of the most popular open source web browser. And recently, Brave introduced like Leo, which is an AI assistant. And for Leo, basically, so this is a code from the Brave web browser repository. And basically in this, you can see the AI assistant use Mixtral or Llama models. So this is an example usage of this pre-trained model. And basically, there exists this kind of pre-trained model supply chain, and basically engineers, they create some new pre-trained model package, which include like metadata of the model and also like the weights or like some relevant files of this model. And then they push these packages to the model registries like Hugging Face or PyTorch. And as downstream users, you can use like the registry APIs to load this model and develop some downstream applications or develop like new downstream pre-trained models. And then eventually these models can be contributed back as new pre-trained model package and back to the model registry as like a new model. So this is construct like a supply chain kind of thing. And the popularity of this pre-trained model packages and also the supply chain keep increasing. So from 2022 to 2023, the number of packages and also the number of downloads. So this is the top 10% downloads on Hugging Face, almost double. Well, it's more than double. So it keeps increasing, and engineers are using this a lot. So some related works about the metadata for pre-trained models. This is called PTM Torrent, which is one of my work published last year. So basically in this work, we provide a data set including 5 different model hubs. And for each model hub, we have like a different data schema, because each model hub, they include like very different kind of metadata. So we use different data schema to store the data here. And another one is called Href Community. So this is work for Hugging Face specifically. And basically the data set, you use Hugging Face API and collect some relevant information from the GitHub repository, which is relevant to that specific model, and then store that into a data schema and provide some data analysis. So there are some gaps here for these 2 previous work. One is there is a lack of curable or more standardized metadata across multiple model hubs. And second is this does not include like downstream applications or downstream software as part of the model supply chain. And this is missing in the existing data sets. And there is some lack of like measurements on the model supply chain. So this is basically the gaps we are trying to solve in this work. So we present the PITMOS dataset, which represent for pre-trained models in open source software. And basically this dataset include the pre-trained model metadata from Hugging Face and PyTorch, and also the downstream GitHub repository, which reuses models. So there is a dependency here. So the downstream GitHub repository is it depends on the upstream pre-trained model. And our dataset has 2 versions. The light version include only the metadata of this model and also the GitHub repository, which is 8 GB. And the full version, including like all the files, like model weights, like the history of the repository, like the commit history, discussion, or like issue reports. So this is like a larger data set, which is about 48 terabytes. So these are the 2 versions of our data set. And all this data are available open source. So I will share a link in the last slide. So this is the database schema we provide for our database. So this is a high-level overview, and I will provide more details for each part. So as you can see here, there are 4 different colors. So for the blue one, this is the basic pre-trained model metadata. So these are all available via Hugging Face API. And we also have this mapping table. Basically, we map the pre-trained models to the downstream GitHub applications. So these are the metadata for the downstream software or downstream application which reuse this model. And I know that here, this is not like one-to-one mapping. It could be like one-to-many or maybe many-to-one. So a pre-trained model can be used in multiple like downstream repository. And also one repository can use maybe multiple pre-trained models, like the example I just shared, the Brave example. And there is one more, enhanced pre-trained model metadata. So basically this part, we use LLM to extract the data, and this data are not directly available from Hugging Face. And basically we extract this data from the model card. So some specific examples here include like the basic pre-trained model metadata, including like what's the popularity, like the downloads of the model, what's the commit, what's the author, like the license, library, like the tag, language, what's the basic architecture, what is the data set used to train this model. And for the GitHub project, basically this include like examples of pull requests, like issue commits, like what's the label, what's the license for the downstream application. And for enhanced pre-trained model metadata, this one basically we start from the unstructured model card, and we use GPT-4 or ChatGPT to extract this to structured data and store the data into our database. And this example includes like what is the base or upstream model, like the model can be fine-tuned from another model, and what is the number of what is the hyperparameters, what is our carbon emission, what is like evaluation metrics, what is like the specific hardware requirements needed for running the inference of the model or train the model, and what is the model parameter count. So some example measurements using our data set, including like this is the number of parameter, and this is the median number of parameters over time. And you can see here, basically for NLP and multimodal model, this is noticeably increased after 2022. But for audio and computer vision model, this is kind of like stable. And we provide like more measurement of this pre-trained model supply chain in our paper. One more measurement we did is basically this is the pre-trained model and also the downstream application license compatibility measurement. So for this measurement, we use the license data from our database, and we use Linux Foundation, open source foundation table to analyze the license compatibility. So the gray connection here is excluded because this is not included in the Linux table. And the blue ones are compatible licenses, and the red ones are incompatible. So basically, we find that like there are about like 25% licenses are identical, and also there are like 0.24% incompatible licenses in the open source pre-trained model supply chain. And based on our work, we propose some future directions. So we propose 15 future directions in our paper. So basically, this include like just using the pre-trained model data, just use the GitHub data, and also integrating this together. Some specific examples include like what is the factors for pre-trained model popularity and quality, what is pre-trained model naming conventions. Using GitHub data, we can analyze what is the evolution of pre-trained model features, what is the pre-trained model reuse patterns, and integrating these two parts of our data set together, we can analyze like what is testing practices for pre-trained model features, what is a good way to recommend like pre-trained models for like downstream users. So in summary, pre-trained model reuse is like an emerging and novel form of software reuse, and we have only scratched the surface of pre-trained model reuse. And basically, we provide like a lot of metadata for these pre-trained model packages and downstreaming GitHub software, and we can do more research on these packages. And here's a QR code for our paper, and also GitHub link for the artifact, and also our dataset is included in this GitHub repository, and also my contact information. And thank you very much for your attention.
Thank you. So maybe just as a quick question, are you saying that there's a
Yes.
48 terabyte data file that you've put in a GitHub repository?
No, it's not. We just put a link in the repository. It's a global share link, so you can transfer the dataset from ours. Yes.
Okay, good. That makes more sense. Thank you. I thought I must be missing something.
Yeah.
We have other questions?
do you see the size growing and sort of the usability of a large data of a SQL database, like as the size grows? How do you see the usability sustainable over time with this, or is it sort of a one shot to just show things?
Are you asking about like are we planning to like update our database regularly? Is that your question?
Yeah, I mean, yeah, like the database as it sits now, right? It represents a snapshot of what's available at a certain given time. As
Yes.
time progresses, this snapshot would eventually grow. And I was wondering if you had any solution to, because this is the general problem in big data, right? That as data grows
Yes.
exponentially, certain formats like databases will start to struggle in their search space, and the time it will take to just traverse the database to find what you're looking for.
Yeah, I think that's a good question. So for this data set, it's like it's more like a static snapshot of like the Hugging Face data or like Hugging Face model and also the downstream repositories. And what I think what I will be working in this summer is basically I will collaborate with a startup company, and they are basically working on like a live version or like a dynamic version of this database. And basically, if I integrated like our method or like our data collection and also like LLM pipeline into their like system, I think this is like a live database for Hugging Face, which might be more helpful for the users. I hope that answers your question.
Yeah, in a way, yes, it's a very interesting project, and I think it has potential to give a lot of interesting information, even from this part of a snapshot part. It gives a lot of good information, especially for this group to work from, because you can see a lot of the interactions.
Yes, and also I noticed that in the metadata spreadsheet we just talked about, I think most of the metadata in the spreadsheet we have captured those data in our database.
So interesting to note. Thank you very much.
Yep. Thank you for listening.
Great, thank you. So Leila, shall we wrap up then?
Yeah, but I have one more question. So
Okay.
I have seen that that you have done already some statistical analysis on this database that you created, but what other uses do you think that this database could support? What sort of research can be done on top of it?
So one thing I'm working on, one kind of direction I'm working on is basically using this data. So basically I consider this database, the data in this database as kind of like engineering data. And one thing I'm working on is I'm trying to analyze like what is the naming convention of these pre-trained model packages, like how people name this model, like what information is included in the model names, and are this information correct, or like is there any like discrepancies in the model name versus like, for example, the architecture in the model name might have like a mismatch with like the architecture in the model card. So this is one thing I'm analyzing. And another thing I'm working on is I'm trying to use the architecture, basically like the pre-trained weights as like training data to do like some kind of like detection for like backdoor attacks, especially like architectural backdoor attacks for these pre-trained models. So that's like some example usage of this data set. I believe there are more directions, which I propose like 15 different research questions in the paper. So I posted the archived version of our paper here. If you are interested, you can take a look.
Definitely, we will be looking in your paper. Thank you very much. Very nice work. And
Yeah.
well, I'm happy that you have mentioned that there are already some similarities with the initial schema that we are proposing, because that means we
Yeah.
are kind of on track of getting agreements with other communities as well. So
Yeah.
thank you very much. And Dan, yes, I
Yep.
think we can wrap up now. Just let me quickly share again, just in case people have forgotten. Okay, yes, here, share screen. Mhm. So if you have any ideas for new task forces, please add them to the collaborative notes. You can do it right now, you can do it later. With some ideas that you think that we could take over for new task forces. And if you have a task force that you are willing to commit, we would be very, very happy to learn about it, because as you can imagine, being this a voluntary work, sometimes we struggle to keep up with our own deadlines. But if you have any ideas, all of them are welcome. Just let us know. And if you want also to commit, let us know. How to join? This is just a reminder. You can join the group and you will get the emails, monthly meetings, 1:08 a.m. UTC, 1:08 p.m. UTC, alternating even and odd months. You can join any of the task forces, even though there is already some work done. There is still more to do. So any help or contribution there would be highly appreciated. And you can join online asynchronous discussions via the GitHub space, via the open consultation that we will have for Task Force 2 metadata, but also with the literature review that it is still ongoing, the white paper for Task Force 1. And I think with this, we can conclude the meeting today. I don't know, Dan, if you want to add anything else?
No, I don't think so. I just repeat thanking everybody, thanking Wenjin specifically as well.
Indeed, thank you very much to the invited speaker and to the attendees, of course, as well. And yeah, see you around, I would say. Thank you very much.
Thank you, guys, and thank you for holding this for us. We're so few, and thank you very much for holding this repeat session. It's greatly appreciated.
Thank you to all the attendees. So keep enjoying RDA. You can have a coffee and move to the next session. See you around. Bye-bye.
Right.
So, bye-bye.